Yeah, good morning. It's really a pleasure to be here in Tallinn. And I'm really happy to be talking about this topic. It's something that I've been personally involved in for quite a while now. It's something really exciting. I could talk about this for hours. And yeah, so what I want to talk about is Kubernetes. I want to talk about containers. I want to talk about Docker. I want to talk about microservices and all these ideas that are like really exciting. I also want to talk about professional Drupal hosting as well. And yeah, there's a lot of buzzwords there. And maybe before we get started into like concrete stuff, let's maybe just go through a few concepts. So the first one, it's containers. Containers, big buzzwords, been used and abused by everybody. It's so fashionable that even like fashion models are posing in front of containers. Yeah, no, in terms of technology, containers are like nothing magic. It's just a set of tools and practices that make it possible to run applications in isolations, or what looks like isolations. And the advantage of thinking of applications in these kind of container forms is that it's really easy to just very quickly instantiate a new instance of your application that's isolated from everything else. That's one thing, but maybe more importantly, it's very easy to get rid of it cleanly, and it's like it was never there. So containers are really great for yeah, temporary stuff that doesn't persist, things that are, yeah, disposable. And when you think of hosting, there's one thing that you definitely don't want your infrastructure to be, and it's disposable. And this is where Kubernetes comes in. So Kubernetes is a container orchestration system, and what it does is it makes sure that your containers are running the way they should. So that's if they die, that they get restarted. If the nodes dies, so the server where the containers are running, that they should be respawned on our server, that there's enough of them running in the same, at the same time, that when you do updates, that your containers get replaced in the right order. All these things that are actually very complicated to do. And it's the kind of thing like you should never build this yourself. So don't build your own container orchestration. And this is where Kubernetes comes in. It's an open source project sponsored by, well, initially created by Google, but now it's in like part of the Cloud Native Foundation. So a true open source project that has a lot of contributors from like pretty much like the entire IT scene. And the way that you interact with Kubernetes is quite simple. You have a set of YAML files that describe the states that you want to get in the end. So you just tell Kubernetes about your desired end state, and Kubernetes will take care of just creating everything for you. So you don't tell Kubernetes how to do it, you just tell it what you want. And these YAML files, there's well, they don't take any variables. They don't take any, like, there's no parameters, no inputs. And the reason for that is just you want to be, like, you want things that are really predictable. So the same configuration should always give exactly the same result. The problem with that is that if you have a set of configuration files that will deploy your Drupal site, these configuration files will only deploy that one specific site. And you cannot do things like having multiple instances of your site. For example, one for production, one for staging, one for development. You also cannot use the same configuration for multiple projects, even though they might all be using the same kind of infrastructure with PHP, MySQL, and so on. So it's a bit limiting there. And this is where Helm comes in. And Helm is a package manager for Kubernetes. So Helm is a set of template files that take some inputs and then will generate Kubernetes configuration. And what's nice with Helm is that you can create arbitrary instances of your Helm chart. So a package in Helm is called a chart. And yeah, and then you can create multiple, like an arbitrary number of instances of your chart. And this can be used to create multiple environments or use the same configuration for multiple projects. And if you looked into this, you might have seen there's already a Drupal chart out there. And actually, the thing that we're doing is we're also creating a Drupal chart. Why do we do that? And this goes back to the topic of professional Drupal hosting. So there is a chart out there. It's actually quite similar to the official Docker image for Drupal. And if you look at it, it's pretty obvious that this was created by people who went on Drupal.org, read the documentation, and just like, oh yeah, this is the way that people use Drupal. Just install Drupal 8, log in, and just click around. No, this is not the way that we do professional Drupal hosting. Do you use any of those practices in your project? I see some hands raising. I guess if I were to ask, does anybody not use any of those? So Node Rush, configuration management, Composer, and all these things, like, yes, we take those for granted. These are the way that to build and to develop with Drupal. And all these things are missing from these charts. And this is what we are doing. So we are creating a Helm chart for Drupal that integrates all of these practices. But yeah, we didn't actually start with just like, hey, let's create a Helm chart. That's not a goal in itself. What we wanted to do is kind of revisit the way that we do hosting, not only for production hosting, but also hosting as a basic tool that we need to develop applications. So the first principle that we had is stand on the shoulders of giants. So we don't want to create everything ourselves. There's some great stuff, Kubernetes among others. And yeah, so we really want to take advantage of everything that's out there, whether it's an open source project or a hosted service. Second thing is it should be self-service. And not self-service in the sense that anybody out there with a credit card can just come to us and buy some hosting. No, self-service within our organization. Because I believe that developers should be able to try out things, create new environments, be independent, not have to just create a ticket and say, hey, I would like to have a server to try something out. This really slows down innovation. So giving people, empowering our developers and letting them create the things that they need, set up environments, set up configuration as with full freedom. This hosting, well, in order to be self-service, it needs to be simple enough so that people can use it without a lot of support. It should just work out of the box, but at the same time, it needs to be flexible enough to address at least the most common use cases, and I would say even the ones that we typically see in projects that and we do some pretty complex projects. So we want to have something that will address all these things. So having a basic setup that's not flexible enough to address the project that we do, it's not useful. And there it's a kind of it's a compromise. And so we need to see how much flexibility do we want to have, and how much power do we want to give to our developers. And this is something that I think we have reached a pretty good balance now, but this is definitely something that might change on the organization, and it will probably also change over time. Also, one thing that we see is that we're not getting this right on the first start, and even the new stuff that we do, yes, it's great, we think it's great, and then at some point it's going to be obsolete. And one of the challenges when building this kind of system is it's very easy to add something that grows over time and gets bigger and bigger and bigger, and at some point nobody understands what all these things are doing. So having a system where every component is not only modular but really replaceable, it makes it possible for us to have an evolving architecture. And one key component here is semantic versioning, so that each of the system that we use has a version, and we know when we can deprecate things, we know when we can remove things, and we have some good ideas of the dependencies that we have in the system, so we can also tell what version is used where, and that really makes it possible for us to get rid of things in the future. Then things should be cheap, and not hey, €9.99 per month for hosting or something like that. No, it should be cheap enough so that people can really create environments without having to think, hey, where do I need to get to like permission? Where do I get the budget for this? Innovation should really be should be cheap, and so that means we can just try out things. The infrastructure that we build should be reliable and transparent, because I think everybody's experienced that at some point you get some hosting from somewhere and then it doesn't work. And not only it doesn't work, but you have no idea why it doesn't work. And so we want to build something that's really reliable, used in production for high traffic sites, but at the same time we want to have a system that's really transparent. So everybody gets access to the log, or developers get access to the logs. And when something goes wrong, you should be able to look under the hood. There's no finger pointing and saying, hey, who's responsible for this mistake? It should just be, hey, there is an error somewhere in the system, and it's a collaboration between the operations team and the developers to really see, hey, how can we improve this? And I believe that transparency is a really key point there. That's very often missing from commercial hosting offerings. Also, it should be technology agnostic. So we have been a Drupal company for many years, but this is not the only technology that we do. We do an increasing amount of Node.js, React, a lot of stuff with Elasticsearch, and we know there are going to be more technologies that will come in the future as well. And so we don't want a Drupal hosting that has some other stuff grafted onto it. No, this is a system that works for Drupal, works for Node.js, should work for Java, work for Golang, whatever you want to have. It should also be infrastructure agnostic. So we have some clients government clients that need to host on specific clouds and specific, maybe on-premise. We would like to have everything in one place if possible. Other clients want to say, hey, we have this dedicated AWS account. Could you please host things there? So we need to be able to host in a lot of different situations. And Kubernetes actually provides this kind of common API that makes it possible to, at the moment already, host on any of the major cloud providers and also on-premise if needed. And last but not least, we believe in open source. We believe in sharing the stuff that we do. So what we are doing, we are actually putting a lot of different solutions together. We believe that the value in there is the expertise. The software that we build, actually, hey, might as well share it with everyone. It gets better. And so, yes, we are doing everything we do here. It's all accessible, and you can contribute as well. So rather than showing you how it works, first I'm going to show you what's the developer experience. So when you start a new project, you clone this base repository, then you enable Circle CI using your GitHub credentials. So we use GitHub for the whole repository management. And then using your GitHub account, you can log into Circle CI, and you automatically get access to the right repositories. So the only thing that you need to do there is just enable building for this repository. Then, as usual, you create your composer lock file and your yarn lock file. So you just run the initial composer install, yarn install, nothing specific to our infrastructure. You also create your basic site installation and export your configuration. You push the changes to your repository, and that's it. So what happens is that when you push to GitHub, of course in a feature branch, because you never work on the main branch directly, so you create a feature branch, and then you have these checks here. And then when you click on one of those checks, it actually links you to Circle CI, where you actually get all the output of the logs. You see what happened. You can even debug the build process if needed. So you can really see everything that happened, timing information, all of that. And then at the end, you get with this one message at the end of the output that says, hey, we deployed your site, it's available here, give it a URL, it's protected by basic auth, so that things don't get accidentally indexed or just not too available. And we can say, hey, yeah, here are the credentials. So that's something that's, yeah, it just, like, as a developer, you push your code and you can get to every single part of the system that you need to access. So even though we are using different tools, the way that we integrate together means that developers just can follow a red thread that leads them to the information that they need. So how do we build this? Well, one of the difficult things with container-based architectures, it's often like the complexity that there is in terms of like, how do you visualize how the different pieces interact with each other? Do you use a time-based approach? Like what happens in what order? Where is the data stored? How do the different pieces of software interact with each other? It's a little bit tricky. So what I'm going to do, I'm going to start from the inside with things that are well known, the code base. So what do we have in this code base? Well, we forked the Drupal project from the Drupal Composer initiative. This is widely used, and we modified it to fit our needs. So we added a few opinionated things. We're using Yarn and Webpack for the front-end build process as a default. The settings.php, we commit that to the repository, and it's already configured to put things in the right place and so on, and also read the database credentials from environment variables. We set the configuration as it should be outside of the web root. We also have a dedicated PHP-CS for linting. So PHP-CS configuration for linting that's a bit more flexible than the official Drupal coding standard, just so that it's good compromise, something that you can use in your project. That will not get in the way of doing productive work, but still lead you to write better code. Yeah, so that's what we have in the code base. And then from this code base, so we build the code base, run Composer, install all of that, and then from that we create Docker images. And we have 2 Docker files. They're actually quite simple. The base image is our own Docker image that includes PHP and all the extensions that you need for Drupal. And here's the difference compared to the official Drupal image for Docker. This one does not have any code base into it. It doesn't have any PHP files. And the reason is that we actually use it with our own code base. So we copy all of the files into the Docker image. And after this point, we don't move files around anymore. Once we have this Docker image, this is the way that we move our code, or that we deploy our code to all the different environments. So this is the one for PHP-FPM. The one for NGINX actually looks very much the same. You might notice that it's in a different location. So we built the PHP image out inside of the Drupal root, and the NGINX image inside of the web root, so it only has things that it needs. And we also add a Docker ignore file, and this Docker ignore file, we specify things that should not be built into the image. So we have things like the changelog files. We don't want to accidentally deploy this. We also have things like the core tests. They are like very valuable. It's really like having a framework that is well tested is very important, but these are not tests that we'll be running, and definitely not running them on a deployed environment. And that's actually a pretty sizable chunk of code, like about 1/3 to 1/2 of a Drupal code base is actually coming from the various tests, not the tests that you write yourself, the tests that come with the framework. So yeah, let's just save some bandwidth and not deploy those. And also in the NGINX image, we don't include any of the PHP files. This means that actually we have better security, because the NGINX container only has files that it should be serving, and everything else should not be there at all. So now we have these Docker images, and the way that we deploy them is using a Helm chart. So our Helm chart is actually public, and we published also a repository, so you can download things with Helm. So Helm install under Drupal. So yeah, that's you can look at the code yourself there. So what is in a Helm chart? Well, there's a definition. That's actually pretty boring, not very interesting. We also have some dependencies. And you can see here, we are not defining ourselves how to deploy MariaDB. We use the existing Helm chart, and that's part of this notion of like, hey, let's stand on the shoulders of giants. Let's use stuff that's already out there. Same thing for Elasticsearch. We don't want to configure, like, to define how to deploy Elasticsearch ourselves. We can collaborate with others on how to do that. And then we have these Kubernetes template files. So if you're familiar with Kubernetes, you've probably seen these kind of files. The difference that we have is that we have placeholders and variables that can be injected. So what you see here, for example, is those the release names. So whenever we create a release, then we are going to have a dedicated set of names for all of our components. So yeah, this is also something that works out of the box quite nicely, but this is the mechanism how we inject those kind of variables into the files. And then where do these values come from, the things that we inject into those templates? And the chart itself has a values.yaml file that define the default values, actually. And you can see we spent some time documenting everything. So how many replicas do you have? Basic auth credentials, any kind of, well, of course, the images that you want to use, things like the cron jobs that you want to run, how much CPU and memory you should allocate to your containers. So there's a lot of things. How do you run, like, how do you run stuff after like a new installation? How do you update stuff? Any PHP, any configuration, how much files storage you want to have. So there's like a lot of things. You don't need to know all of them, but these are the default values. And these are the things that you can then upgrade, well, override. And the way that you override is that you have your own configuration file in your repository. So typically the chart itself is not in your repository, it's just published. And then you just make a reference to it, but you pass your own variable overrides. So for example, for this project, I want to say, hey, I want to enable private files because it's an intranet and I need to serve private files. Maybe I have a bigger code base that really needs a bit more memory, so I'm going to request more memory for my container. I want to run cron, like not once an hour like the default. For some reason, I want to run cron every 5 minutes. I can configure that. Maybe I have something else I want to run. So it's not cron, something that I want to run like, hey, like once a day or some other schedule. So it's really flexible. You can specify the things that you want to override. And you can specify things per project, and then you can also specify some configuration for specific environments. For example, on production, we actually want to have a dedicated configuration that will be considerably different. So I don't only want one copy of my container, I want 3 copies because I want high availability. I want a dedicated domain. I want like 2 dedicated virtual CPU for each of these containers, 4 gigabytes of RAM that are really going to be dedicated. And I'm focusing on performance and scalability, whereas the default value just focus on development environments that should be cheap and very quick to deploy. And maybe I want to have an external database, so I'm passing in the database credential to a hosted service, and I'm not going to deploy a database within Kubernetes. So there's a lot of flexibility that we have, and then here the production settings will really depend on your project. But we really have the flexibility to to use, to set whatever resources we want, and that also means that we have a lot of flexibility in adapting to the needs of each project. Could look at the templates. Yes, we have a deployment to a Kubernetes deployment that will take care of deploying the pods and the containers that we have, persistent volume claims, service cron jobs. A lot of these like Kubernetes-specific components, we're using all of that. It's really great, but I don't think that it really makes sense for me to just go into the details. There's some excellent material on Kubernetes, some good introductions, so I'm not going to focus on that too much. But there's one thing that we see is that actually when we grow these kind of like these configuration files and we add more logic to them, we end up with, like, this is our deployment file, and actually you can see it includes a few different like sub-templates, so actually the resulting file is much bigger than that too. And yeah, how do we manage this kind of complexity? It's actually quite simple. We use unit tests. So who here has some infrastructure that's unit tested? And you know what? It's a good feeling, because whenever we make big changes, we can just run those unit tests and see, hey, would this deployed configuration actually change based on the changes that we have made, the flexibility, adding options, and all of that? And it really makes it super easy to refactor our application, our infrastructure, and still have this confidence to know that we're not breaking anything. So having this kind of approach where even your infrastructure is unit tested, even in the few months of development that we've put in this, it really has paid off. Another thing that I think is worth mentioning is, so we have a service, and a service determines how you access a set of containers in Kubernetes. So you don't access the containers directly, you access a service that will then point and load balance to different containers. And one of the things that we're using here is a system called Ambassador. Ambassador is an API gateway for microservices. And what it lets you do is you just add one annotation to your service where you specify a few metadata and you specify like the domain that you want to connect to, and a few other, and actually the service that it's going to point to. And with this, it means that we can easily let each of our individual environments just say, hey, I'm going to have this domain. And so we can point all the DNS to this Ambassador load balancer, and it will just redirect the traffic automatically to the right environments that we have. And this is great because we don't need to have a central place where like we have central data that needs to be updated every time that we add a new project or that we remove one, and so on. Each project just determines its own name. And actually, this is something I forgot to mention. This release name, the standard that we use is a combination of the GitHub project repository and the branch that we're deploying. And that means that using our continuous integration system, we can deploy a dedicated environment for each single branch. So whenever you create a feature branch, push some code to it, it's going to be deployed automatically for you. Get a dedicated environment. You can test that everything works. You can test big changes and only merge those once you know that it's not going to affect the work of others. So everything is tested before it's merged back. And not only the application, but also all the infrastructure changes, server configuration, and so on. Another thing that we have here that I think is a good example is how we create cron jobs. So Kubernetes has a cron job mechanism, a cron job object, that will automatically create new containers for each task that it needs to run. And in our values file, we have an array of different cron job definitions, and we just iterate over all of those, and then for each one, we just create a new definition, pass in the command that we want to use, pass in the schedule, and we just we get to create an arbitrary number of cron jobs, Kubernetes cron jobs, very easily. So yeah, these are all things that are really, like, once you start working with it, it's just like super simple, really nice to work with. And then, well, I mentioned we have Ambassador to manage things like the load balancer and the traffic and so on. And these are not inside of each of the containers, each of the projects. These are things that we want to work in general. And so we have a dedicated Helm chart for the cluster itself, for all the support services, things like Ambassador, also things like an NFS server. This is one thing that it's still a bit of a drawback at the moment if you want to be able to mount the same volume, so to be able to access your files, so the Drupal files, both from PHP and from NGINX, or if you want to have multiple environments, you need to have a volume driver that supports that. And well, at the moment, Azure and IBM Cloud both provide something like that, like as a service. The major cloud providers like Google Cloud and AWS don't have this yet. And so that means that we need to have an NFS server to provide this kind of shared storage within the cluster. But that's something actually that will be replaced soon. Also things like logging and monitoring and just defining how data gets collected. We don't want to rely on teams or a project team like defining how their monitoring infrastructure should work. This is something that we want to do in centralized place for our operations team. And yeah, any new project should automatically be monitored and logged. And the setup for this is going to be done in that central Helm chart. And then there's all the things that we have outside of Kubernetes. So actually provisioning the servers themselves, the cluster nodes, provisioning the DNS, provisioning the service accounts that are able to deploy stuff on our cluster. And the reason we do this, and we want to automate this, and actually we're doing this with Terraform, the reason we do this is not because we want to have a lot of different clusters. We'll probably have one for production, one for development. Maybe large clients will want to have a dedicated cluster, but we don't necessarily want to have a lot of clusters. The reason why we want to be able to automate the provisioning of a cluster is so we can just quickly set one up, do some load test, try to break it, and then once we're done with this exercise, just get rid of it, and really increase the stability and the trust that we have in the system through this automation. So how do things fit together? As I mentioned, the first step is a developer pushing to GitHub. But actually, before you have something to push, you probably want to develop that locally. And for this, we currently use Lando. And that, I guess, like, is anyone not familiar with Lando? Okay, yeah. So Lando is actually a local development environment that's based on Docker that really lets you quickly provide new environments. So even though it's also based on Docker, we still have a separate configuration. But we see that the local development environments really need to have specific configurations because the way that you deploy code locally is very different. You just mount your files into your running application, whereas when you deploy stuff, you really want to have fixed containers that are not going to be changing. But yeah, Lando is like, it's super easy to get started with. This is something that we are already using. But yeah, everything that I've been talking about with Kubernetes, it actually starts from the way here. We don't actually expect anyone to install Kubernetes locally on their laptop, even though it's possible and it actually works quite well. But yeah, so we build locally with Lando. We push our code to GitHub. GitHub pushes or triggers a build on Circle CI. And as part of the build process, we build the code base. We push things to, we push our images to a Docker image repository. This is typically going to be hosted in the same data center as the Kubernetes cluster itself. And then we trigger a deployment on Kubernetes that will ask the images from the Docker registry and just instantiate the resources within Kubernetes. And what's nice with the system is that we have individual components that work well together, but that are actually pretty independent of each other. So at each step, we have standard APIs, and that means that it's possible for us to replace things. And this is something that's, yeah, as I mentioned earlier, we want to have an evolving architecture. We think that Circle CI is great. We don't know if it's going to be here forever. Maybe in 2 years we'll have a better solution. So it's really nice to be able to see, hey, we can actually easily upgrade and switch to other systems if needed. And actually, since we published this code that we have, well, we published this shortly before Drupal Europe, and some people got interested and started using it. And they're using it in a different context than we are. So what they're doing, they're not using GitHub, they're using GitLab, and GitLab CI for the build process. And then they're not using Google Cloud like we are using at the moment, but they're using Azure, because they're a nonprofit organization and they got free credits there. And so we see that it's really, well, we wanted to have something that's flexible, but it's really gratifying to see, hey, it actually works in practice. People can take this package that we've built and use it in different contexts, and it just works. But yeah, so at the moment we're using Circle CI, and well, the Circle CI configuration it's just a YAML file with a set of bash commands in there. Git-like configuration or configuration for most modern CI system will also be quite similar. So here we have actually 3 different jobs. The first one is to just validate stuff. So we want to give quick feedback. In our case, we run PHP-CS. So just warn about any issues, white space, potential errors with your code, and so on. So yeah, we want to provide quick feedback. The next step is the build. So what we're doing here, we're running composer install with a few additional parameters. Nothing really complex here. And what you see before and after is just the caching mechanism for Circle CI. And that means that we're taking a checksum of the composer log file, using this as a cache key, and that means that unless somebody is installing something new in the system, so adding a new composer package, then composer install would just run instantly because it's loading things from the cache. And that means we have really quick deployments, and this is key, because if you want to have a pull request-based workflow where you really expect things to wait for deployment to be done before they ask for a review, then you really want to have things be quick, because the last thing is, like, if things take too long, people will kind of bypass the system, or maybe just start doing something else, and then you will end up with delays. The build process for the front end is actually pretty much exactly the same thing, just with yarn instead of composer. So running yarn install, also caching the result. And what's nice is that since we're caching the front end and the back end code independently from each other, it means that front-end developer, whenever they're pushing code, they're most likely not touching the back end, and then that part will be really quick, and then vice versa, a back-end developer that pushes code will not be touching the front end, and that code will just like be there already. And then the last step, as we are done with a build process, or we have our entire code base, then we just log into our Docker repository, we do a build for our image, and we push it. So we have the NGINX image and the Drupal image that we are building and then pushing to the repository. The deployment step, so actually creating the Kubernetes resources. The first thing is we log into the Kubernetes cluster. And yeah, so this is a set of 5 commands that kind of specify where the cluster is and so on. It's a bit verbose, but yeah, it doesn't really hurt. And then the interesting part, so we have Helm, and we upgrade our Drupal chart, well, upgrade or install, depending if it exists or not, a new release And this, again, is based on the project name and the branch name. And it's called, well, and we installed the Drupal chart. This Drupal chart is, well, actually, I think there's one line missing here. Yeah, so we pull it from our own repository, which is public. We set the environment name, so this is mainly going to be used to determine the domain that we want to generate. We pass in the PHP image and the NGINX image. These are the images that we just built in the previous step. There's a bit of a shortcoming at the moment with Helm and Helm version 2, and that's going to be fixed in version 3, the way that secrets are handled. And so for certain secrets that need to be consistent across multiple builds, we need to pass in the database root password. So these are set as secrets in Circle CI, and then we pass them on to the Kubernetes cluster. For the namespace, we set the namespace to the repository name. And that means that each project will be deployed to its own namespace. And a namespace in Kubernetes really makes it possible to isolate resources, and that provides some good separation so that different projects in the cluster will not be able to see each other. And then here we provide our own SILTA.yaml, so our own values file, where we'll have all the project-specific configuration, and we just wait. And then it takes usually, well, actually deploying a new version of the code goes within a couple of seconds, and the part that takes time is just running Drupal installation or updates and things like that. And yeah, the system that we built, it's a combination of multiple technologies that we're putting together, that we're combining. Well, we never wanted to create a hosting product. Like, we don't see this as an interesting business opportunity. But nonetheless, we have a system that combines multiple things that we see, hey, we need a way to talk about this without saying, hey, the system with Circle CI and GitHub and Elasticsearch and Terraform and Kubernetes and Helm. And so as we were looking for a name, we decided to call this system SILTA. SILTA is the Finnish name for bridge, and we thought that it's a nice picture, a nice idea to kind of bridge the entire development experience from the start of development, innovating, trying out new things, all the way to production hosting. So why do we do this? When we already have our own hosting solution based on Ansible and UpCloud, and it actually works quite well. It's stable, it's battle tested, it's affordable. Why do we do this? Well, there's a few different reasons. First one is we want to embrace decoupled architectures. Modern architectures where we are able to use the right tools for the right tasks, and a project will not be based on a single solution. So yes, Drupal is great, but it's not going to be the only thing that's going to be part of our application. And to be able to do that, we really want to have an architecture that really provides that, so not running everything on dedicated virtual machines that need to be provisioned explicitly. We want to just be able to say, hey, I want a React front end, and that's going to be a dedicated container, and you just deploy that, and it's there. So I really believe that this decoupled approach is like, it's not only about running JavaScript, it's about building long-lived architectures that evolve over time. And this is really something that is enabled with these container-based architectures. We also care about hosting best practices in general, not only Drupal best practices. And we've been spending a lot of time just not only going to Drupal events, but also other kinds of events to see what is out there, how are other companies and software teams building stuff, and we see that there's a lot of inspiration that can come from there. And, well, also to answer the question, why do we not just use a commercial hosting? We need a hosting infrastructure that works for us. And of course, it needs to be stable, reliable, cheap, or affordable, like good value for the price, and all of these things. But most importantly, we need to have an infrastructure that works for the way we work, because hosting infrastructure is really one of your main development tools. And if it's not working with you, if it's not supporting your teams in how they work, then you end up with a tool that's not good for you. And what we see is that we have been able to build something that really works for us and really works for like larger development teams. We've actually had some interest from larger European organizations, so not necessarily agencies, but organizations like public institutions that have maybe 100 developers inside of their own team. And having this kind of infrastructure that fosters innovation, that fosters experimentation, can really make a big difference in the velocity and the rate at which we build stuff. And last but not least, hey, we like to do cool stuff. This is really fun. This is really fun to work with. But also, like one of the aspects is that Kubernetes is really revolutionizing the hosting world. We see that this is used everywhere. This is making a huge impact, and it's really great to be part of this. So I'd like to thank our sponsors for making this event possible. Thank you very much. And yeah, do you have any questions?
Do you have any plans to create a website explaining all this stuff in detail?
Yes. So, well, there is already some documentation in the various components that we have. If you go to github.com/wunder.io/SILTA, we have this is the main project which only has documentation. That specific documentation is well, what's there is up to date, but it's not very in depth, and it doesn't explain that well how the different pieces fit together. So yeah. So there's some documentation available. Whether we turn that into a website, actually, why not? It just takes a little bit of time. Yeah.
Questions, anyone?
I'm not sure if I missed anything. One of the things that I liked about one hosting provider that we were using was whenever you did a pull request, it would create an environment just for that pull request. Any plans on doing that with this?
So we already built the branches, and the idea here is like since we control the resources and we can also say, hey, if you have 20 branches, that's okay, as long as you're actively developing the site, and then when you stop developing, you kind of shrink down. So we don't only deploy when there's a pull request, we deploy pretty much every time. The one thing that's missing is, like with testing pull requests, is testing not what the content of the branch, but testing the resulting code from what you would get if you were to merge the pull request. So a mixture of the content of your feature branch and the target branch. And that's actually something that Circle CI doesn't support. So it's something we've been very happy with Circle CI, and that's the one thing that's missing. So there's actually nothing that speaks against that, but it has to happen at the continuous integrations level. One way that we've found around that is actually GitHub lets you enforce that all the branches need to be up to date before you can merge them. And so if we do that, then pretty much like you have to rebase your branch or merge the master branch into your feature branch, and then at that point you pretty much get the same thing. Yeah.
Questions?
How much time takes from push to get to see the actual result in the web?
So it kind of depends on the site. And of course, the first push when you create a new environment, it will take a bit longer. The default is to just create like a new installation. So run just site install, and I think the like average deployment times that we see from the push to the site being available, it's about 3 minutes. And in some cases, well, that's actually for some projects that don't have a log file or something like that. So it will vary, but yeah, I think 3 minutes or less is actually something that we're aiming for.
If you say it's 3 minutes, what part of it takes most of time?
It's actually building the Docker images and moving the images across the network. So that's like the biggest optimization that we can do is store the images in the right places. Yeah.
The examples were about Drupal 8. What about Drupal 7?
Yeah, so actually there's nothing specific about Drupal 8. So we have the template works for Drupal 8 out of the box, but you can also just run whatever build process you have for your Drupal 7 site. It could be drush make, could be just like commit everything to the repository, could be like maybe even a Symfony application that's built differently. As long as you have your code base and you can just package that code base into a Docker image, then actually it works. And that's one of the things that we see. Yes, we are actually at the moment testing the migrations of Drupal 7 project, even a legacy project that like Drupal 6 with the entire code base in there. And also we have a team of people who are doing Gatsby work, like a static site generator, and we also have the possibility to just host like a fully static site. So it's built built on Circle CI, and then we just take the result and like host it directly. So we have a lot of flexibility, and that's also something we want to take all of the projects along. So this is not only for new technologies and like the hot stuff. This is really something that we can use for every single project that we have.
Thanks.
I have a quick one. Do you have a main reason why you chose Docker instead of Vagrant, for example? Or have you tried it with Vagrant?
Sorry?
Do you have a main reason why you chose Docker instead of Vagrant, for example? Or have you tried it?
Like people have started to hate Vagrant for years. I mean, Vagrant has the advantage that, especially for Macs, it's still a little bit faster. What we saw though, like comparing Vagrant and Lando locally, is like Vagrant is faster to execute, but Lando is like much easier to set up. So would you rather spend a few hours setting up your Vagrant and just it always break because there's a new release and it just doesn't mount NFS properly and all of that, or would you prefer to have a Lando and maybe instead of like response time from 500 milliseconds, you get 600 milliseconds. So I think it's a compromise, but I think it's we've seen that most developers have been very happy with the switch.
Fair enough. Thank you very much, Florian. So we have actually a token of appreciation for all the speakers. So thank you very much for sharing the knowledge with every one of us.
Thank you.
Thank you.